Okay, howdy folks. First I'm going to conduct a little experiment before I march on. This is, it's no alcoholic drink, sorry for you folks. And it's not so important that you don't see me entirely, but if so. This is plain honey. I can take it and eat it. You can buy this in any supermarket where you like. This is plain honey. I use this stuff because it's viscous. It is more viscous. It's not like water. Water is not so viscous. And tastes great. I have some items here, except next to my phone, but I don't need that right now. And I'm going to conduct you a little test. What I have here is like honey. I have an aluminum foil, and I have a copper coin, and I have a flame, and I'll explain it to you later. And I have a little tweezers here, pair of tweezers. What I did is rolling this aluminum foil up to something like this. I squeezed it and I pressed it into firmly into a little bowl. Yeah. And what I'm going to do is I'm going to drop it into the honey. And as you can see, it floats. And maybe it will sink very slowly, but at present it floats. And because aluminum is pretty light. It's pretty light, one of the lightest metals that we know. Airplanes are made of aluminum and other light materials, and you can also maybe see, at least I can see it, some air bubbles, so releasing it from air bubbles. But then, even then, it floats. Okay, now I'm going to drop in the copper coin. But because, this is aluminum foil, I forgot to do that. But because I want to eat the honey afterwards as well, I'm going to sterilize it. I mean, I like honey, so I want to sterilize it first. I don't want any bacteria on my coin and in my honey, because I want to eat the stuff later on. Okay, I'm going to cool it down. So you cannot say that this will do the heat is doing the trick. It's not. Copper is heavier, more heavy than aluminum. Well, we're going to show. I'm going to drop it in here in the honey. Yeah. Okay. Cool down. Okay. And watch what happens. It drops down to the bottom of this little vessel, little beaker. So you can see that there is a difference in if the density of a metal is higher, the quicker it's going to drop down. Okay, why have I performed and conducted this little test? Well, one of the things is that people that believe in a Big Bang, people that believe in the nebula theory, people that believe in abiogenesis and evolution, they have all one thing in common, and that they say, well, the Earth is billions of years old, and the universe is billions of years old. Well, that's what they have in common. Well, then I have a question. If the Earth is about 4.5 billion years old, and is formed, according to the nebula theory, from a hot molten mass, which is liquid, that's why I use the honey. By the way, this is not hot. Why is it that if it's liquid, that in a hot molten, in the beginning of the supposed beginning of the nebula Earth, so to say, it was hot. It was extremely hot, according to theory, and it was molten. It was totally liquid. You couldn't stand here on Earth because you would sink to the bottom, or you and you would burn, of course. But in that case, why do we find heavier metals on the top of this Earth? Why do we find copper? Why do we find gold? Why do we find mercury? Why do we find uranium? Why do we find iridium, etc., etc., etc.? Because if it's hot and liquid, as you can see, heavy metals go to the core, the nucleus of the Earth. Next to that, apparently, and I didn't know that at first, but I can imagine because I'm a chemist, and of course you can imagine it too, because of if you go to the dentist and you had a mercury filling of your the hole in your tooth, and a couple of years ago they had mercury fillings, mercury alloys fillings for your tooth, and I still have them, unfortunately, but they get out in a couple of months, I hope. But then metals can mix. Well, it is known that the nucleus of this Earth is metal, is steel, iron. And it happens to be that metals are easily mixed with iron. And that is apparently those heavy metals like uranium, iridium, osmium, etc., and mercury, they mix very well with iron, chemically spoken. Well, if that's so, then why are these heavy metals, after 4.5 billion supposed years, what are these metals doing on the top of the surface? What I would expect in the nebula theory case is what you exactly see here, that the heavy metals drop to the core of the Earth, and that the lighter metals like aluminum, etc., and sodium and potassium and lithium and so on, that they would remain on the top of it, because the heavy metals would sink to the gravitation center, in this case the core of the Earth, which is iron, a big huge amount of iron, liquid iron. Especially if the internal of the Earth, and that is true up till now, that's proven true, that you can see that at the volcanoes, that the interior of the Earth, if this is the crust of the Earth, and the interior is liquid. We see that in volcanoes where the liquid comes out, lava we call it, etc., etc., etc. So what are these heavy metals doing on the Earth's crust? If the Earth supposedly formed about 4.5 billion years ago out of a nebula of material, and then gravitated to the planet Earth. So science cannot explain that very well, because all the heavy metals, gold, etc., 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 they should be at the core of the Earth. Yeah? And that's what science can explain. I found a site here where you can also see the densities of the metals, and in case of copper, I'll find it, aluminum and copper. I'll find track it down for you, if they are in this list, by the way. Aluminum has a density of 2.7 grams per cubic centimeter. Or per liter it will be 2.7 kilograms. So if you have an amount of about this much, that's a liter approximately, then this would weigh, for aluminum, this would weigh 2.7 kilograms. If you have, let's say, copper here is copper. It has a density. If you have a liter of copper, pure copper, then it would weigh 8.96 kilograms, about 9 kilos. It would weigh a liter, and so on. You have iron. Gold, if you have a liter, weighs 19.3 kilograms. Iridium, one of the metals, is heavier, even heavier. That's weighing, where is it? Where is it? Iridium. Oh, here. 1 liter approximately this amount is weighing 22.5 kilo. Iron is weighing 7.9 kilograms for 1 liter, approximately this amount. If you imagine here a cube within my hands, then that is approximately 1 liter. Magnesium in the contrast is weighing 1.7 kilo per liter. So, and mercury is 13.5 kilo per liter. Molybdenum is 10.2. Neptunium is 20.2. Nickel is 8.9. Osmium 22.6. Palladium 12 kilos per liter. Platinum is 21.5 and plutonium is 19.7. And one of but we find all those metals. Tin is 7.3. I'm looking at tungsten is 19.3 and uranium is 19.1 and vanadium is 6. Well, we find all those metals on top of the surface where we live. What are these metals do on top of where we live? Well, they're heavy, pretty heavy. We expect the lighter elements like aluminum and sodium, etc. We expect them to be on top of the surface of the earth the most because they're lighter. And I don't know what is silicon. It doesn't say here directly, so to see. No, I cannot find it out. But we also find that silicon is pretty heavy. So, and we know that the earth, the sand, which we stand on, the rocks, is mainly silicon. But what is it? What is silicon doing here? It's supposed to be in the core of the earth, not here on top. No? We expect here the lighter elements, the lighter metals, not the heavy ones. So that contradicts the theory of the nebula theory. Well, it wouldn't be a surprise that if God made this earth, He designed it to be inhabitable. Because if here we would live on sodium and lithium and metals like that, life was impossible, because sodium is very aggressive, is very corrosive. If you would have a pure sodium on top of your hand, it would burn through your hand because it reacts to air and water immediately. Even if it smells water, it starts to burn, and it will burn right through your hand. So life would be impossible. So only by design, by God's intelligent design, this earth could be habitable for us human beings. If nebula theory would be right, then we couldn't live here, because you were swimming in a pool of sodium if you would be alive anyhow in the first place. So science has no answer to this. The only answer to this is God created this world, and that's why you're here. God created you, He loves you, and He wants you into heaven. And the only way to get into heaven is by Jesus, by the cross. What He did, He sacrificed Himself, etc. And for forgiving your sins, for following other gods, for following lies like the evolution theory and abiogenesis and nebula theory and Big Bang stuff. That's all baloney, folks. God created this heaven and the earth, and He wants you and me in heaven. And I like to see you in heaven just as much as God wants to see us all in heaven. Okay, this is the story I wanted to tell you. Bye.